Welcome back. This is Mr. Tipton, and today we are going to continue our study of probability by learning about sample space. Sample space is the set of all possible outcomes, all the different things that could happen when you perform an experiment or perform some kind of test. There are a couple of different ways that we're going to talk about how we can represent sample space. And that's going to be by listing the possible outcomes and also making a tree diagram. So let's look at a few together. We're going to start out by looking at some lists. This one says to make a list to find all the ways Abby, Bobby, and Kathy can sit in a row. Okay, we're going to use A for Abby, B for Bobby, C for Kathy. That's why those capital letters are underlined. But we need to make a list of all the different ways that they can sit in a row. It's going to help us when we make our list to be organized. Since we're dealing with the alphabet, we should probably start, or we can start, in alphabetical order. Abby, Bobby, Kathy, sitting in a row. When you're making your lists of all the possible outcomes, it's best to only change one thing at a time. In fact, I even think I'll write that down. Only change one thing at a time. One thing at a time. I'm going to leave Abby where she is, sitting first in the row, and I'm going to switch Kathy and Bobby. So what I have here, these are all the combinations that I can get with Abby sitting first. There's nothing else I can do except for ABC and ACB. So because I'm all done with Abby sitting first, now I'm going to move Bobby to sitting first, and then I'm going to list the other two in alphabetical order to start with. Bobby, Abby, Kathy. Okay? I'm going to continue working on Bobby sitting first. My only other option is Kathy and then Abby. And these are all the outcomes that have Bobby sitting first. So now I'll move on. I started with A, then went to B, and now Kathy is going to sit first. And going alphabetically, we have Abby and Bobby. And one more with Kathy at the beginning, then Bobby, oh, that's a B, and then Abby. Okay, so there are 1, 2, 3, 4, 5, 6 different ways that Abby, Bobby, and Kathy can sit in a row. And we've used a list to find all those ways, to find all of the outcomes. Let's do another one. This says to make a list to find all the possible outcomes of flipping a coin twice. Alright, well, when you flip a coin, what are the options that could happen? We've got heads, and we have tails. So flipping a coin twice, let's see, we could get heads, and then heads. We could get heads, and then tails, and that's all that starts with H, or starts with heads. So we could get tails and then heads, or we could get tails and then tails. Okay, there are only 4 things that could possibly happen when you flip that coin twice. Alright, so making a list, I recommend using letters or numbers or whatever it is, and start your list by doing things in alphabetical order. That'll make it a lot easier. Let's move on to tree diagrams. This says a car can be purchased in blue, silver, red, or black, and it also comes in 2-door or 4-door. Make a tree to find the sample space. Alright, so here's what a tree diagram is going to look like. I'm going to start with my first set of options. We've got blue, blue, silver, red, and black. Alright, so here are all 4 color options. The other option that is in this problem is whether I want a 2-door or a 4-door. Well, the part that makes it a tree is you can either call these, roots or branches, whatever you want to call them. But basically, you can get a blue car in a 2-door or a 4-door. You can get a silver car in a 2-door or a 4-door. Same thing with red, same thing with black. So what's the sample space? How many different options of car are there? Yeah. 1, 2, 3, 4, 5, 6, 7. There are 8 different options. The sample space is 8. 8 different kinds of car that you could get. Another one of those, I've got another one with coins here. Use a tree diagram to find the probability of flipping a coin 3 times and getting 3 tails. Okay, so this one first, let's make sure we answer what we're asked. It's not just asking for the sample space, but we're wanting to find the probability of flipping the coin 3 times and getting 3 tails. This time, I'm actually going to make my tree go left to right. It doesn't really matter to me what you do if you go top to bottom, left to right. As long as you do it correctly, I'm okay with it. Let's say we flip heads the first time. What could happen on the second time? Well, we could get heads again, or we could get tails. What if we got... Alright, and then after the second flip, what could happen? We could get heads, or we could get tails. If the second flip is tails, again, there are two options. Oops, I'm going to undo that line. We could get heads, or we could get tails. So let's go back, and let's say the first flip was tails. What could happen on the second flip? We could get heads, or we could get tails. And then on the third flip, we could get heads, or we could get tails. You've always got 2 options each time when you're talking about flipping a coin. There's either heads or tails. So the sample space, if I read this from left to right, there are 1, 2, 3, 4, 5, 6, 7, 8 different combinations of things that could happen. There are 8 different possible outcomes. And we know when we figure probability that our possible outcomes goes in the denominator. And what is our favorable outcome? What is it that we're looking for? We're looking for the probability of getting 3 tails. Alright, so how many of these 8 options have 3 tails? Well, it's just this one down here at the bottom. Tails, tails, tails. So the probability of getting 3 tails is 1 out of 8. There's only one of these 8 combinations that have all 3 tails. All the rest of them have at least 1 heads. Alright, sample space. This year again we're looking at lists and trees. And that's pretty much it. If you have questions, write them down. And we'll practice tomorrow. See you soon.